So today I will talk about sorting algorithms, and I will take it in English because there are so many words and different scenarios which are already used in English. So that's why I don't want to translate it into German or English or Swedish or Austrian or whatsoever. That's why I would like to take it in English. And this will mark the first step of sorting algorithms, and this will be the first part of sorting algorithms. And I will continue talking about sorting algorithms on Friday. And I really was eager to take the lecture today because sorting algorithms are an essential part of the exam and will always be a part of the exam and will mark something very essential for you guys in the future. So it doesn't matter where you're going to work in the future, you will always have to deal with sorting algorithms. And in some scenarios, and in most scenarios, we just use some libraries, we just use some paradigms, but especially when you're a computer scientist, it's very important that you understand how such algorithms are made of. And especially when talking about algorithms, it's very important, or it's very useful to talk about sorting, because many different scenarios in an algorithm can be explained by, for instance, sorting. And sorting can be very, very useful to understand other ways of algorithms. So that's why I thought I have to take a lecture today about sorting. As I know, you have a lot of different material as well from Navic, and I won't interfere with Navic there, but I just want to give you some additional information and maybe some very useful information to understand sorting. And of course, you can watch YouTube videos, and of course, you can find lots of different stuff there as well. But just to tell you how different things sometimes happen and how sorting algorithms are made of can help us for understanding other algorithms as well. So that's why I wanted to talk about such algorithms today. The main guideline is like stolen from the internet, somewhere different places. And I built like a table of contents, which I will talk about. And today we will talk about the introduction of sorting algorithms, and we will deal with bubble sort, selection sort, insertion sort, and maybe heap sort. I'm not sure if we come to heap sort as well, but those sorting algorithms which I have listed are probably the most important in my opinion. And as we always focused on your marks, I would say those are very important to understand. As I already said, it's not about understanding Python, it's more understanding algorithms. And that's why today also I always give you a Python example, but I also show you how such algorithms are implemented in other programming languages as well. Sometimes I just used C++ because that's my favorite programming language. And sometimes I will use Java to show, okay, maybe this is somehow easier, maybe this is somehow more trickier. And it doesn't matter what the outcome and what's your future profession will be. I always know that you have to learn different programming languages. And as a computer scientist, you will always have to learn C#. You will always have to learn Python now, and something else like a web-based programming language, maybe JavaScript or something else. But in my opinion, to learn C++ is also very important, and C#, of course, as well. And of course, as we know, Florian would say, all the web-based programming languages as well are very important, which is true because many things are done with programming languages, web-based. So when we want to sort something, we have the challenge that we want to that we have like an unordered list of items. Maybe it can be strings, maybe it can be integers, maybe it can be doubles, but also it could be like a list, it could be a dictionary, it could be a map, and we want to sort the values. We want to find a way how to sort it. And we could have like philosophical questions here at this place, because what's sorting in some occasions, if we have like a dictionary, if we have something like a unordered list where we have like strings and integers and doubles. So this can be also tricky what sorting means, especially when we are using algorithms then afterwards. So what's the main, what's sorting then? If we have like numbers, of course, numbers is easy. If we have strings, or okay, in most occasions, we will have like alphabetical ordered sorting or other ways of sorting. But even for different scenarios, we have always to take into consideration what's sorting there. So this can be quite complex and can be quite intense. Sorting can be like very time consuming, and sorting can be a lot of performance consuming for your computer. And in many occasions, you have to find the best sorting algorithms fitting your data. So it doesn't mean in most scenarios, okay, most sorting algorithms will work this way. But if your data is already sorted, or if your data is already generated in some special way, special sorting algorithms can lead to better results than other sorting algorithms. So this is sometimes not so easy to understand. Otherwise, I would always use the same sorting algorithm. But in some occasions, it's very important to understand what's lying beneath, what's the basis. Because if your data in artificial intelligence, if the data in your medical image processing is somewhere completely random, or if your data is somehow just already a bit sorted, this will lead to a completely different outcome of your sorting algorithm. And this is very important to understand, because most people think, okay, I would always use the same sorting algorithm. But if your data is different from other places, this can be very, very difficult. So sorting can be very complex, and it's not always trivial. It can be very complex concerning time, concerning programming skills, concerning memory consumption. And that's why we will always have to deal with different sorting algorithms. Otherwise, because I remember when I was a student, I thought, okay, I will always use the same sorting algorithm, bubble sort or quick sort. But in some scenarios, it's not advisable that you should use this. If you have any questions, of course, just put it into the Zoom chat. When we're talking about what are the basic understanding of the sorting algorithms, we have to think about scenarios where we can understand what's happening with the algorithm. And especially when dealing with sorting, it is often very advisable to think about playing cards, to take it from there as well. And this is helping you guys when you have to build algorithms. When you have to build algorithms and you have no idea how you should solve this algorithm, or if your algorithm you are using is much too slow or is much too time consuming or is using much too much memory, I can always advise you will find something which is in the world, which is existing in the world, as for instance, cards. You want to play cards maybe, or you have some items and you sit there on the table, you discuss with other people and you draw and you maybe find diagrams how you can solve such algorithms. And that's why sorting algorithms are so important for us, because it's not because sorting is so wonderful and so special and so funny and it's so popular. Of course, it's a part of many algorithms and it's a huge component in many different applications, but it sounds kind of boring to us. But understanding sorting in different scenarios and understanding how you can conquer an algorithm, this is very useful. And that's why I can always suggest, if you have to sort your own algorithm, and sometimes you have to find an algorithm which does the same for you and which does exactly this task you want to do it, I can always recommend sitting there, talking with your friends, talking with your, if you don't have friends, talk with your colleagues or sit there as well, or just talk to a computer, I don't know, but sit there, draw something and find a way to make it, to visualize the problem and to visualize how it could be done. And that's why I tried to give you such basic strategies to, for instance, explain a bubble sort, or explain a selection sort, or explain an insertion sort. And if you want to have like a bubble sort and explain it by playing cards, well, I would pick up all the cards from the table and always swap adjacent cards if they are not out already sorted, and just always take two of them. I will deal with this afterwards and explain it to you in more detail. But of course, if you just always swap two of them and two of them and two of them, it will take some time, but in the very, very end, you will have a whole list sorted. This is kind of the basic idea of bubble sort. And in the very beginning, I would always say you have to have an understanding of how it should be done. And then you should find a way how it's implemented. And then you should think about, okay, what's the runtime? And then you should think about how it could be improved. If you think about selection sort is always very advisable to visualize it with playing cards as well. You will pick up the lowest cards from the table. And then you will always find the next suited card onto your deck. So this will add up a card and a card and a card and a card. What's very important to see here as well, all the cards, all the items, all the data is left somewhere else, which lead us afterwards to a very important component, which means like memory inside, memory outside, or like inside or outside, and so whatsoever. But the memory, where the memory is situated, is very important for us to understand. And to give you an example with playing cards, how insertion sort could be, it's like you pick up any card from the table, and then you will find always the next suited card from the table in a rising position, which also will lead you to an order to sort your cards from the lowest to the highest number, for instance, which can also be and can also lead to very great results there as well. And that's why we have to think about, okay, what's the time consuming, what's the memory consuming, what's the O notation, the big O notation, so what's the runtime. But also there are two other components which are very important to us, and this is stability, which can be like how stable is the algorithm, which means, okay, are all your elements like not changing the amount of numbers, or is it like working properly? Is it like leading to memory out of bounds exceptions whatsoever? But also one other component which is very important is this algorithm. Is it recursive or is it iterative? In most scenarios, when we create an algorithm, we think iteratively, because that's for most people, that's the way we think. Because in my head, you don't want to have my head, but it's like in my head, it's like I think like A, B, C, D, E. But as we already know, some tasks can be solved recursively. And if we have, especially sorting, which in most scenarios does things over and over and over again, recursion is sometimes very well suited for using sorting algorithms. So sometimes it's very important. So if we talk about memory consumption or memory requirements there as well, it's always, or there are always two words or two synonyms which are always widely used. And this is in place, which means all the memory is inside of the data, which is all the data, if I have additional memory consumption, is independent of the input size. I don't have to use extra data to make it work. Or out of place. And out of place is that I have to use additional memory to make my algorithm work. I have to put my cards somewhere else, otherwise my algorithm won't work. So especially when talking about algorithms, always take into consideration the runtime. What's the best runtime? The big O. What's the best runtime? Is it O of n? Is it O n square? Is it O n n multiplied log n whatsoever? What's the best? What's the average? What's the worst case for your big O? As we know, big O, complexity, efficiency, very important. Second component, as we all know, what's the memory consumption? You can have the best algorithm in the world, but the memory consumption can be just crap. So that's why please be advised that memory consumption is important, but is your algorithm working inside your data? Does it have to use the data somewhere else? Do we have to store the data somewhere else? Do we have to create 5 arrays to make a temporary memory for the data and then copy it from A to B all the time? Or do we have out of place? Do we have to have additional memory somewhere, depending, completely depending on the input data? Is it recursive or is it iterative? And stability. Stability can be quite tricky and can be very hard to understand. The first sorting algorithm today I will talk about, and I sent you already the PowerPoint. You can have like a detailed look on it. I won't talk about it so much because it's very easy to understand if you take some time for yourself and try to test it out. But I wanted to give you my summary of my most important sorting algorithms. And the first one I am going to deal today is bubble sort. Bubble sort is one of the most popular sorting algorithms, and I've used it quite a lot of times. I've never implemented myself, but it's mostly widely found in most programming languages. So the basic structure of all the sorting algorithms I am talking today is, first is always how it's working, then code example, mostly C++, and then Python, always Python example, and then complexity, and then how it's done. So first is, okay, as we said, I will give you an illustration afterwards as well. You will always compare 2 adjacent items in a list, and if they are already sorted, it's fine. If they're not sorted, you just switch them and you bubble up. You will see what bubble up means afterwards. You bubble up your array more and more, and in the very end you will have a sorted list. For instance, if you just take this graph into consideration, you will understand how bubble sort is working when you just take a closer look at this graph. In the very top, you will see, okay, you have like a small bubble, which you will always compare 2 adjacent items. And for each iteration, you just go 1 step ahead. And if it's sorted, you continue. If it's not sorted, you swap the items and then you continue. This is the basic idea of a bubble sort. And I will give you an illustration afterwards as well. It's like if you take a closer look at a pseudocode, in my opinion, it's always very important to have like a pseudocode. It's like you have like a loop and you iterate through all the items and you always compare 2 adjacent items. If they're not sorted, if they're already sorted, it's fine. If they're not sorted, you swap them. That's the basic idea. It's like a bit more in detail. Also, if you want to sort something in the very beginning, always think about what are the main constraints in the very beginning. What are the basic operations in the beginning? Or what do I have to take into consideration that my algorithm working? This is kind of, I don't know, if you wanna add a sum of an array with a lot of integers, the sum should be initialized to 0, like a basic idea, or like a basic constraint. That's what I mean with constraints. If we program stuff, you would always have to think, okay, what's the basic constraint in the very beginning? And that's why my example is always like, what if you want to create the sum of an array with integer values, you will just set the sum to 0. That's like your basic constraint in the very beginning. This is meant like with row number 2, initialize x changes to false, because in the beginning you will set all the exchanges to false, and then you just compare value by value. You will understand what I mean when you see my code example. So if we consider the performance of the bubble sort, it can be very well, it can be lead to amazing results and gorgeous results when most of the items are already sorted. It can be big O of n comparisons, even though big O of 1, if it's already sorted. But in most cases, if we have like a random number of data, this can be quite a lot time consuming. So this is like O(n) squared, big O, as we know. But if our data is already quite sorted, then this is quite good. So bubble sort can be very useful. I wanted to give you an example how it's done in, actually this is not C++, this is Java, but it doesn't matter. It's like, it doesn't matter, but it's just, I always want to puzzle you a bit, because you don't know Java, you don't know C++ so much, but it's about, in some occasions when you get a job and you don't have an idea what you don't have an idea of a special programming language, maybe C, or you get an algorithm in C, and you have to implement it in your programming, in your favorite programming language, and you don't have any manual, you don't have any documentation. But then you have to be a computer scientist, and you have to understand what's going on. You have to understand what's going on, and you have to re-engineer the problem. You have to find a way. And even though this looks kind of different what we are used to, you will understand what's going on, because you know, okay, we're iterating through the list, we're comparing adjacent items, and if the item is not true, we just you just leave it like this. If it's already sorted, we leave it like this, and if it's not sorted, we just exchange the values. And that's why, to me, it's very important that you always see different code examples, that you're not become just people who are quite good in Python programming. You should be computer engineers, and you should be able to understand code from different scenarios. And of course, we're dealing with Python, so that's why I gave you a Python example as well. And you just have to Google bubble sort in Python. You probably find it. And I'm sorry to have not formatted it in very well meta, but it's just also a good example. Otherwise, it's just calling the method. But here it's like for j in range, blah, blah, blah. And look at the pseudocode and look what's done here. And at the very bottom, you will just see how it's just called, okay? But to understand the algorithm, to understand the method, look at how the method is done. Of course, you will find probably different implementations of the bubble sort. I just found this one a very well explained solution of the bubble sort. So if you have an exam, if you have like an exam and you should explain the bubble sort, it's not so much about Python programming, it's more about to understand what's going on. Okay, we iterate through a list and we always compare adjacent items. That's very important. And then we change and swap it. That's the main idea of the bubble sort. So if you have exams over sorting, it's always about the idea. It's always about complexity. It's always about recursion, and it's always about memory consumption. The next, actually, I thought I give this paradigm, the principle, in Norwegian as well. Just if you, I don't know, I just try to explain. I just try to translate it with Google Translate and my Norwegian. So I don't know if it's perfect, but maybe because I wanted to take this lecture today in English because all the stuff is in English. But even if you want to have like a Norwegian explanation, this is also very useful. What I can also suggest is watching YouTube videos about sorting, like bubble sort. How is a bubble sort explained? Is also very useful, but very important to understand the algorithm. I would never focus so much on the programming language in the very beginning. I would first understand what's going on. If we have like an illustration of the bubble sort, I wanted to give you an illustration what's going on for each iteration, and we have like a sorted list, which is unsorted list, which is not very much of a big effort, but we see when we go through all the different items, we always compare two adjacent items. And as you see all the iterations, iterations, you will see at the very bottom, the overall list will be sorted. This is the first one. So this is how it's done, and you see, okay, it takes quite a lot of iterations. It takes a huge amount of iterations to make this work, but it will work. That's the main. I just gave you another example. This time it's in C++, and it's like in German as well, but it doesn't matter. It just will show you how it's done. Just have a look and just try always to explain. No, it's not in C++. It's in C#. Oh, it's in Java as well. Looks like Java, looks like C#. Okay, and the main preferences of the bubble sort are like, it's iterative, it's not recursive, it's stable, it's in place, which means the memory is in place. It doesn't need additional memory to just we don't have to put the cards somewhere else. That's like to understand the memory consumption. You just can work with your data and you don't have to outsource the memory somewhere else. And it can be very efficient for data which is kind of pre-sorted, which is kind of sorted already, but it's not perfectly sorted. That's like, in the worst case, we have big O of n squared. In the best case, I always thought it's like O of 1, but it's like O of n. That's the best case. And in average, well, I don't know. Average is. The second, as I said, I will talk about 3 sorting algorithms today, not of all the bunch, but I will talk about 3 of those sorting algorithms. And the second one is selection sort, which is also very easy to understand and which is also very popular. And selection sort, if you think about the playing cards again, the cards are still on the table as well. And if you have like, if you want to understand it, if you want to understand it in a very way, it's like, you just pick. I had this example from before. You just pick the cards, and you always add it at the end, or pass the card on the next one, and the next one, and the next one. And at the very end, it will be situated at the position where it has to be. In most cases, it can be O(n) squared, a big O(n) square, because it's like, it has so many comparisons inside. But you will understand, and I will just show you how it's done and illustrated, that you can understand what's going on here. To talk about the pseudocode again, it's like, okay, as you look on the positions, which can be also a bit distracting in the very beginning, but you will understand it completely when I show you the illustration afterwards. And you also have to iterate, like at the bubble sort. You have to iterate for the list, and then you will jump to the next step. You won't bubble it up all the time. You will just jump the item to the next place. To understand this, I will show you this example. Just give you, make it bigger. As we have our data here on the left side, and then what's been done here. So just, if we have like our scan, and the smallest is 20, and we scan through the row, and then we swap 35 and 20. We insert, or we select it, and put the 20 to the position. So we select the lowest item and put it to the front, and then we continue. We scan 20, 65, 30, 60, 35. We scan it again and put the lowest again to the front, and so on. So scan 1 to 4, and the index is changing again. So I just have another iteration for you, another illustration for you to understand what's happening. But just, if you want to understand this pseudo algorithm, it's also very advisable to just think about playing cards here again. So I have another illustration, because I think it's just, I think this is kind of okay already, but there's another illustration. Here is like Java example, which should be a bit distracting, which should be a bit puzzling for you guys, but it's also to understand, okay, how it's done in other programming languages. Just have a look at it and try to understand it, what's going on, because it's very important to get used to different algorithms. Looks like this. Extends means just inherited. But if you have like a Python example now, this will be looking like this. And that's very important, that always the minimum, the least minimum error item will be put to the first step. And then if it's okay, it will be left like this. And if it's not okay, it will be swapped. And then we completely do it. The great thing in Python here is that we can do it in a very neat way, and swapping the elements to sort the array will be done in this kind of line, which is very nice in Python, I would say, and can iterate it through. Very important that the index, when using selection sort, is always changing. It's always changing. at the very bottom, we see how the call could look like. It's very interesting as well. Selection sort. I have another slide about preferences. It's iterative again. It can be unstable, so it can be leading to problems, and it can also be problematic, not really trivial. It's in place again, which means I don't have to use additional memory. And in most scenarios, that's my personal experience. It can be tricky if we have a huge memory amount. If the data is huge, it can be kind of tricky, or if we have to think about it as well. So I'm not a big fan of it, but it's very important for your exam and very important, especially as a computer scientist in general. Runtime in most cases is O(n squared). It's the runtime. And the last sorting algorithm I will talk today is insertion sort. And insertion sort, if we compare about it with playing, if we compare the situation with playing cards again, this is kind of, I will take a random, I will take a card from the table. I will take one from the table. And that's why I used this example with playing cards again. And I will take one example, I will take one card from the table. And I will always pick one. And every time I pick another card, I will add it to the list. I will add it at the proper place. And in the very beginning, as you can see this example, we have like 3, 6, 10. Then we pick a card, then we have like 3, 6, 8, 10. We pick another card and we have like 3, 6, 7, 8, 10. Insertion sort, in my opinion, is very useful and has great advantages among the sorting algorithms, because understanding this algorithm can also be very interesting to understand other algorithms, which have nothing to do with sorting. So maybe it's just inserting customers from other places, or etc., etc. So like in not pseudo code, but it's like thinking about the algorithmic way. That's why I wanted to give you like this example. Always like we pick one item and then we just take another item and then we put it to the position where it belongs. And the amount of sorted items is just incremented by 1. And we have to think about memory, of course, and we have to think about where at the position. So the indexing can be quite tricky, but also in some occasions it can be quite a good algorithm to work with. To give you this example, I'm sorry for the formatting again, to give you this example, and this time we don't begin at the very beginning or at the very bottom. We begin to pick something, to pick a random value, and then we just iterate, and we insert the values which are fitting to this position. I would always suggest also to watch YouTube videos on sorting. I'm a huge fan of YouTube general, but especially with sorting, they always have like very nice visualizations of sorting algorithms. So if you just watch it, then you have it in your head. And if you have it in your head, it's easier to remember it, because in the very end of all the lectures, you have like 7 or 8 sorting algorithms, and you have to have an understanding and you have to have the comparison in your head, how it's working. So that's why it's very important to illustrate it and visualize it, that you can remember it afterwards. So the main difference to bubble sort and selection sort is like where you put the, where you get the value. And just to get the value, we get a card from the table. You take one card from the table and then you begin the overall procedure. If you have like a Java example here again, yeah, the first step is like insert, like a chord, and then you go through all the values, and yeah, it's not visualizing the step of taking one value, but it's like in general. But the Python example here is much better in my opinion. I'm sorry for the formatting again, but it's like in the very beginning you see like the basic structure here. What's the basic structure and like the basic constant. But then it's like for E in range, as we always know, it's like we have to have loop and then move the elements that are greater to one position and change the index. This is also very important. Change the position and change the array. And then here's like the call, but also we have a while in the for loop to change the values and to change the current position. Also recommended, if you want to understand algorithms, if you have understood how it's working in like a basic way, but you want to have more understanding how it's done in an implementational way, it's also useful to debug. It's also very useful. But just to give you like a Python example, and as I said, it's very important to see different different programming languages as well, how it's done there as well. And sometimes it can be very tricky. In most occasions, on many occasions, it's O(n) square, so big O(n) square, like selection sort, or like the worst case of bubble sort as well. In some occasions, in the, if I'm lucky, it's like big O(m), so it's like this one. But it's like if we see an illustration right now, you